Luxottica started life as a manufacturer of eyewear frames, and this is still our main activity. However, over recent years, we have produced nearly 90% of the non-graduated lenses used in our sunglasses. Luxottica embarked on the production lenses for sunglasses thanks to the acquisition of Persol, Ray-Ban, and most recently Oakley, which are all brand names known for having contributed know-how to lens production. Lenses have traditionally been produced in the Persol plant in Loriano, near Torino, Italy. The materials used to make the lenses are crystal and various types of synthetic resins, CR39, polycarbonate, and polyamide 12, also known as APX. The Loriano plant is where all additional treatments take place to increase the performance of the lenses. Let's take a closer look at these materials, beginning with crystal. Crystal is a particular type of glass with special characteristics that grant it optical qualities. It is shiny, extremely hard, transparent, homogeneous, and maintains its shape. Cutting-edge processing systems result in optically perfect crystal lenses that are particularly thin, yet extremely lightweight and resistant. Take into consideration that they pass the drop ball test, a quality test during which steel balls are dropped onto the lenses from a height of 1 meter and 30 centimeters without them breaking or being deformed. Now let's move on to the synthetic resin lenses. Let's begin with CR39, a resin that is outstanding for being more resistant to scratching than other plastic materials and requires no scratch-proof treatment. Lenses in CR39 can be easily produced and surfaces can be treated with a wide range of uniform and graduated colors. Then there is polycarbonate, a material with an extraordinary impact resistance that far exceeds the strictest standards imposed by law. In fact, in addition to the drop ball test, polycarbonate lenses also pass the high-mass dart impact test, which consists of a 500-gram steel dart being dropped onto the lens from a height of 1.3 meters without the lens being perforated. Polycarbonate is slightly lighter than CR39, but is a bit more delicate, requiring a scratch-proof coating to increase its resistance to abrasion and scratching. Finally, there is a new synthetic material being used more and more frequently, polyamide 12, also known as APX. Even though it offers high mechanical resistance, polyamide 12 lenses are totally compatible with all the materials used in making frames. It is important to know that the chemical composition of polyamide 12 is not compatible with alcohol. For this reason, contact with this type of solvent must be avoided. Now let's look at the main treatments used in making lenses. Let's begin with coloring, that limits the passage of light rays of a specific color, thereby guaranteeing protection. It is therefore important to choose the color of a lens not only according to its aesthetic appearance, but also and above all for a functional reason, selecting the colors that are best suited to the sensitivity of the eye and take into account how the eyeglasses are used. For example, a darker color is better suited for extreme luminosity, while a lighter color is best for limited luminosity. Another of the main treatments is scratch proofing, which consists in the application of a special resin on the surface of the lens to grant improved resistance to scratches and abrasion. Another treatment of fundamental importance is polarizing, which helps eliminate polarized reverberations of light reflected from shiny surfaces like water, snow, ice, or even overheated asphalt or sand. Finally, our lenses are also subjected to anti-glare treatment to neutralize rays reflected from the lens itself. So, as well as frame manufacturers, we also maintain important quality standards concerning our lenses.